size. Now when you look it up, you're sure it's going to work. Okay, in the last video, I summarized everything that we'd said so far about hash maps. Let's talk about two nice touches that you're going to want to put in your implementation. We want to be able to return the total number of things in the map in constant time, so that'll be a size method. And we want to make our own equivalent of key set that will return a list of all of the keys that we've ever added. And ideally, we want that to run in constant time as well. So if we were going to think about this kind of naively, we might say, all right, for getting the size, let's loop over all the locations in our array and count how many of them aren't null. And that's the same as how many objects we've ever inserted. But this would run in big O of n time because we're looping over our entire array. Same thing for key set. So for key set, we would loop over everything and add all of the keys that are inside our objects to an array list and then return it. But again, I have to loop over everything. So a better approach would be to have an int field for your object that gets incremented every single time you put something into the hash map. So now when someone asks for size, you don't have to loop over everything and count. It's like you're counting each time someone puts something in. But that only takes constant time to add 1 every time someone puts something in. And then that number is always up to date. And then size can just return that count that you've been maintaining. So same idea for key set. Let's make an array list of strings that will hold all the keys for our object. And then every single time someone puts a new key in, let's add it to the list of our keys so far. Just a quick note here is you actually want to make sure that they're not trying to replace the value of an existing key. So before you just go ahead and put your key inside your list, you want to check to see, is the key already in the list? But don't try and run the contains method because that's going to loop through your array list, and that'll be big O of n for you. Instead, run the hash function on key, which is constant time, and then see if something's there. And if something's there, then you know that that key is already stored, and so it must already be in your array list. So with that kind of nuance aside, the general idea is the same, that you're going to be putting your keys in every single time you run the put method, and then when someone runs the key set method, you just return that list that you've been adding to in an ongoing basis. Okay, so you've got 3 parts to your assignment today. First, you're going to start from the implementation, the partial implementation that I've provided. It doesn't handle collisions. It doesn't do anything with load factor. Instead, it just displays collision at index whatever and overwrites the old value whenever collision happens. And it's got a lot of missing methods. So you're going to start just by filling in the missing things. So complete the get method using my pseudocode, implement the size method so that it runs in constant time like we just described, and implement key set so that it runs in constant time like I just described. Remember that you're going to need to modify the put method in order for those 2 methods to work the way that we talked about. Okay, step 2 is you're going to be able to handle the idea of a load factor. So create a field called load factor, or maybe max load factor, that will be the maximum percent that you want your data structure to be filled. And then whenever you exceed the load factor, you'll double the size of your array and rehash, reindex, reinsert all of the previously stored data into the new array so that we'll be able to look them up properly. Then pause and come back and watch my other videos where I describe 2 other collision handling strategies. I'll describe linear probing and cuckoo hashing. And then the last part of your assignment is to implement one of the collision handling strategies that we talked about, chaining or linear probing or cuckoo hashing. If you want to go wild and try and make your own fancy thing after that, you can, but you should start by doing one of these 3. This part you will probably extend into homework, and this part is due before next class. Okay, good luck, everybody.